Okay, another 30 amps fuse to test. I want to check its temperature at 60, 70 and 80 constant current load. Okay, let's zoom in, start. Here. Zoom in. The fuse is around 30 degrees. Okay. Let's do 30 amps, 50 amps to start. Amps. It is working at 44, 45 degrees. Okay. 47 degrees, less than 50 degrees at 50 amps, 49.5. Okay. Still 49 degrees, less than 50 degrees. I will say 50 degrees. It started the test at 30 degrees. Now it is at 50 degrees, which is a low temperature. Okay, let's do 60 amps. 60 amps. $65 degrees. 66. And we see the cable and connector around 50 degrees. Okay. And the fuse, let me zoom in. The fuse is at 70 degrees. Okay, 60 amps. Let's try 70 amps. 71 amps. Okay. The fuse is at 90 degrees. At this current, the steel fuse reaches more than 250, almost 300. The zinc alloy fuse is lower than 100 degrees. 70 amps. Okay, let's do 80 amps. Amps. Okay. $120. Less than 130 degrees. The cable is around 100 degrees and the connector 70 degrees. 90 degrees the cable, the connector. Okay. Fuse is at 130 degrees. Let me zoom in. 130 degrees. 140. Okay. We are at 80 amps. Okay. 140 degrees at 80 amps. 79.9. As I mentioned on the previous video, this zinc alloy fuse is capable of higher current levels than the steel fuse. This fuse doesn't reach this level of current, constant current. Let's see, 145 degrees. I can, it's confirmed that the 30 amps fuse could work at 80 amps without melting the fuse. I will wait another minute or so to conclude the test. Let's see the temperature. $143, 345. The fuse is at a safe temperature level. The connector reaches almost more than 100 degrees. The cable more than 100 degrees. Okay. 30 amps is plenty, is enough for Power 2 batteries. My electronic load. It's very hot, but this fan is at 9. This is a 12-volt fan, but it is currently at 9 volts to reduce its noise level.